Now let's take a look at parent functions along with translations and other transformations. In 1.9, we talked about what the parent functions actually look like, and that's an important thing for you to know. So I'm just kind of taking a step back from that. Family of functions is a group of functions that have similar characteristics. So anytime that you have a family of squareds, you're looking at anything that has a squared in it. Okay, x squared. You're looking at the linears, it's anyone that has an x. The cubics, anyone that has an x cubed, and so on. The parent function, so that's the one that we're going to be using over and over and over again, is the simplest function with the defining characteristics of the family. So it's the most simple of all of the family of functions. And you'll kind of see we'll be using the word parent. Every other graph that we're making that's not the parent function is in the family. Okay? So here's what we're going to be doing to those parent functions. We're going to be translating them. Translation means just to move a figure, but keep it the same size and shape. A transformation is to change the figure from the original. So it can be changing the shape. It can also be moving. A translation actually can be a transformation. Should have added that in there. The reflection is we're creating a mirror image across some line of reflection. The reflection lines that we're going to be doing are either x-axes or y-axes. Okay, we're not doing a ton more with those. And so in general, let's take a function. So I've got the function x squared. I'm going to do or look at doing these translations to it. So let's take say that I have an equation that says that I have x squared plus some number at the end of it. It means that the parabola has moved up that many units. For example, if I've got x squared plus 3, that means that I'm moving this function up 3. Now remember that this function is a u-shape that when I put it on a graph, the u-shape goes here, okay, and the vertex is at the origin. That's an important thing for you to know. I'm taking that parent function, that's the parent, okay, here's the parent with the graph, and I'm going to translate it. I'm going to create some other member of the family, and this x squared plus 3 would be another member of that family. So then if I move on and I take that parent function and I subtract something, that means I'm going to be moving it down. Okay, so I add something on the outside, I go up, subtract something on the outside, I go down. Okay, in the case of x squared minus 7, I'm going to go down 7 units on my graph. Here's where it gets a little bit tricky. If I put inside the function, which usually it means that I'm putting it inside parentheses, I'm putting it underneath the square root, I'm putting it inside absolute values. Okay, anytime that I'm looking at putting this function or this adding or subtracting inside, it actually does the opposite of what you would think. You would think that minus c would move something to the left, but it doesn't. It actually moves it to the right. So parabola moved to the right c unit. So for example, I have in parentheses, I have x minus 2 quantity squared. It's still a u-shape because it has the squared, but I'm going to move this function right 2 units. So it's the opposite of what you would think if you put it on the inside. Same thing here if I've got f of x plus c. So I put the plus c on the inside. I put it on the inside of the absolute value. I put it underneath the square root. Okay, all of those things are on the inside. So I take the parabola and I move it left c units. So the example x plus 4 quantity squared actually goes left 4 units. But the fact is that it still has the same parent. Okay, it's still in the same exact family as all the rest of these. It's still a U-shape that starts at the origin, but I've moved or changed it. Here's the reflections. If I put a reflection on the outside, it reflects across the x-axis, and essentially what that means is that I turned it upside down. Okay, so this graph that has this reflection is the U-shape, but it goes upside down. Okay, so that's a reflection across the x-axis. So all the same movements happen. I still move things left and right. I still move things up and down if I needed to. But as soon as I put that negative up front, then I reflect it across the x-axis. I turn it upside down. And then the last one is if I put that negative on the inside, that means that I'm reflecting across the y-axis. So every point on the right-hand side becomes a point on the left-hand side, and so on. We don't use this one a whole lot. But you need to know that it follows the same logic. If I put things on the outside, it's actually going to be changing in terms of up and down. If I put things on the inside, it's going to be changing in terms of left and right. So let's take a look at a couple examples here. Graph the following and compare the two graphs. This can be done on your graphing calculator. Okay, I'm going to do just a general sketch of what happens here. You can graph it, the first one in the bold option and the second one in a regular option on your calculator. If you have questions about that, I still don't have a calculator that works on my computer, but please feel free to ask about that. And then the question is, how is the second one different than the first one? That's what you're labeling, the transformation. And so when I look at these, I'm just going to graph them. Okay, and I want you to graph them on your graphing calculator. So I'm going to be doing just a regular sketch of them. This first one is our parent function, a linear line. Okay, and that's what we were doing before. We're just naming it and telling me what it looked like. So we named it. It's a linear line, and it looks like this straight line. When I do this to it, when I create this transformation, I'm putting a +5 on the outside. So just from the last thing that we did, this is going to go up 5 units, and it's going to be the same exact line, just up 5. Okay? So the bottom line is then you could always go in and just create an XY table for X, and you could always go in and create a table for X plus 5, and then you could just graph the two, and that would be fine. There's absolutely nothing wrong with that. The problem is that if you choose to do that, you're choosing the slow way of doing that. We had a shortcut of this back when we were doing y equals mx plus b, where when you would take the +5 and say, oh, that's the y-intercept. Okay, and you would plot the y-intercept, and then you would draw the line in from there using the slope. Well, we want to be even less exact than that right now because we're looking at just the transformation part. Well, we want to say, well, that's going to move up 5. Well, that's the same thing as saying that we're going to find the y-intercept at 5. Okay? But you could always fall back on using this XY chart. It will always work. We just want to find quicker, faster ways to do mathematics and become a little bit more proficient at it so that we're not stuck in the Stone Age doing XY ordered pairs. We want to find quicker ways. And so number 2, the transformation then was up 5 for number 1. For number 2, x squared, that's going to be, let me go back to red here. That's going to be a parabola. Okay, it's quadratic, and it's at the origin. And I've got x squared minus 7, so I'm subtracting 7 on the outside. That means that I'm going to move this 1, 2, 3, 4, 5, 6, 7. Move the 7 down, and it's going to look the same way. It's the same exact shape, just went down 7. Okay, so this transformation went down 7. And again, you're looking at this on your graphing calculator. You don't need to do necessarily the graphing part of this because your calculator should do that. The next one, the transformation with the parent function square root of x. The square root of x has a parent function that looks like this. I would recommend always drawing in the parent function when we're doing these problems. And then the transformation that's happening is I put an x plus 3 on the inside. So plus 3 on the inside actually moves this to the left 3. And it looks like the same exact graph, just moved to the left 3. Okay, so this is, the transformation is left 3. Now you can do these on your calculator, you can graph them, but what we're looking at here is a cubic function, which looks like this, except that we're also moving this one left 3. Plus 3 on the inside of the cubic is left 3. I've got another squared, I've got a plus 8, so that's going to go up 8. I've got another linear line that's plus 4, so that's going to go up 4. You can draw those in You can make a graph for them, but ultimately my question was for you to plug them in your calculator. So you should plug them in your calculator and then double check these pieces of information. So here's what it looks like on your homework assignment. And you have already gone through this and you said, well, this is linear and it's going to create a straight line. You already went through the second one and said that this is quadratic and creates a U shape. You already went through the third one and called this absolute value and said that that it looks like a V. Okay. So what I want you to do is I want you to go back and I want you to draw those parent functions in. So the parent function for a linear line looks like this. It's a straight line. Try to draw it as straight as you can. The parent function for the quadratic looks like this. And if you don't have two colors, I'm going to be using two colors. If you don't have two colors, then you should draw it in kind of like a dashed line. Okay. So those are the parent functions. This is not the graph of my equation. The graph of my equation I'm going to draw here in black. I've got x minus 3, so I'm going to take this function and I'm going to move it down 3. And so the function is going to look exactly the same, except that it's down 3. I want the parent function and I want the new function. If you need to do that with an XY chart, then fine, go ahead and do that with XY charts. But ultimately, I want the parent function and I want the new one. You want to be moving towards not having to use that chart, though, the XY chart. And so I've got plus 2 on the inside of this quadratic. Plus 2 on the inside means that I'm actually moving this left 2. And so this graph's going to end up looking something like this. I've got plus 4 on the outside of the absolute value one, so that's going to move it up 4, which means that it's going to end up looking like this. Okay, so I want the parent function either in one color or in dashed, and I want the new function actually drawn in with a solid line. So here's a square root example. I've got minus 2. The first thing is the square root looks like this. I'm guessing the majority of us will not have a second color, so I'll do it in dashed. X cubed. X cubed looks like this. And another x squared, which still looks like a parabola. So I'm taking the square root, the first one here, and I'm doing minus 2 on the inside. Minus 2 on the inside actually means that I'm moving this right 2. So it's the same function, right 2. You don't have to be exact with the points. If you're doing an XY table, you should be exact with the points, because that's what the points are. That's the whole point of that. But what I want you to do is I want you to start looking at the transformation in terms of a faster way of doing this problem. I've got minus 4 on the cubic here, so the minus 4 means it's going to move down like this, which means that it's going to end up coming and looking like that same graph, just move down 4. On the next one, this quadratic, I've got a negative out front. Well, a negative out front was that reflection that we talked about. All that does, I didn't move it anywhere. The origin is still the vertex here, but I flipped it upside down. So I didn't move it anywhere, I just flipped it upside down. So then I can look at some of these things in combination. So if I've got negative x squared plus 6, my parent function looks like this. It's a nice parabola. I've got the plus 6 on the outside. So the plus 6 on the outside means that I move this up 6. 1, 2, 3, 4, 5, 6. And the negative means that I flipped it upside down. It's a reflection. And so my new graph actually looks like this. I flipped it upside down and I moved it up 6. Okay? It's important for you to be looking at this in terms of a shortcut version. Again, you could use the XY chart and that's fine, but I want you to start using a shortcut. On this last one, I've got a plus 1. Well, first I've got a cubic function. So the cubic function is going to look like this. I'm taking that and I've got plus 1 on the inside. On the inside of this cubic, I actually need to move this to the right one. Left one, rather. Plus 1 means left one, so I'm going to move this to the left one. okay, which means my new vertex or my new reflection point is here. But then I've got a negative on the outside. That negative on the outside means I'm going to flip it upside down. So each one of these points is going to go across the x-axis, but basically all that means is that this graph is going to look like this. It's going to go up to the left and down to the right instead of up to the right and down to the left. Okay? So take a look at these. Make sure that you understand transformations. It's an important thing for us to be looking at in order to make ourselves quicker mathematicians. It could be done with XY charts. You can always do things with XY charts. That's like the fail-safe. But we want to move towards doing these so that that the problem becomes more of a quick process as opposed to just plugging in points.